In this video, we are going to learn about classification of signals in signals and systems. Okay, classifications of signals is a very important topic and easy topic. So, first let us understand what is signals and systems. So, signal, I think you people all aware of it. So, let us take one device. Let it be a transformer. Okay. So, transformer is a device. It is known as a system. So it will take current and it is amplifies, right? So this is known as a signal. The current which is moving in and which is coming out is known as the signal. The device is there, right? So this is known as the system. I hope you got the idea on what is meant by signals and systems. Systems are nothing but a devices. Now, in theoretical, a signal is a function that carries information about a physical phenomenon. So, what is signal? Signal is a physical phenomenon. So, it is a carrier information. In engineering, signals are usually represented as function of time. So, how the signal is going to represent? It is in terms of time, okay? Such as x of t for continuous time signal. So, function of time. This is the representation of function of time, which is known as signal. For continuous time signal, you need to note here it is classifying into again subtypes like continuous time signals and discrete time signals. For the discrete time signals, you need to use x of n. Okay. I hope you got the idea with the introduction. In first major classification, the classification is just now we have seen yx of t and yx of n. So for continuous and discrete, right? So now continuous time signal and discrete time signal. First let us go with the continuous time signals. So continuous time signals are a signal defined for every value of time. So if the signal is like this, what is this mean? What is mean by this? It is continuing, right? So it is continuing with respect to time is known as the continuous time signal. So here the advantage is like the signal is defined at every value of time. So it is a plot of time. It is the x of t, like function of time. So we can define every value of time, right? For here we can say, for here we can say, here, at any point we can define the value of signal. So that's why it's known as the continuous time signal. Example, x of t is sin t. Sinusoidal wave is there, right? This is the best example. This is the best example for continuous time signal. Now let us go for the discrete time signals. So discrete time signals are defined only at specific instance of time. So only a few selections we will take. This is known as a discrete time signals. Here we can't define. So what the value here is, we can't define, right? Only at specific instance we are going to take the value. Okay, that is known as a discrete time signal. So it is represented in terms of n, like x of n is sin n. Now let us go for the periodic and aperiodic. Aperiodic is also known as the non-periodic. Okay, what is meant by periodic means it repeats after a fixed interval of t, time t. Okay, suppose this is a graph, right? See, after this is again repeating. So this wave is taking the time interval t to repeat it again. So again in the time t, it is again repeating. Again after this also it will repeat. So repeats after fixed interval t is known as the aperiodic signal. Condition x of t is x of t plus t. So this is equals to the this thing, right? So that's why it is known as the x of t is t plus t. Okay. Now for example, you can note this. You can verify this thing with this also. Okay, what is non-periodic or aperiodic signals means does not repeat. Suppose example, if you take the exponential graph, this will lies like this, right? So it will won't repeat. So that's why it is known as the non-periodic or aperiodic. Okay. Now let us go for the even signal and odd signal. So even signals are symmetric about the vertical axis. What is the vertical axis? The vertical axis, right? So it is a symmetric about the vertical axis. Or you can plot in this manner also. This is also a even signal. Condition for even signal is x of t which is equals to the x of minus t. Example, x of t is t square, x of minus t equals to minus t whole square which is equals to the t square. Therefore, we can state that x of t which is equals to the x of minus t, right? So, in this condition, it is meant by the even signal. Okay. Now, let us go for the odd signal. Odd signal is, it is symmetric about the origin. So, what is origin? This is the origin. It is symmetric about the origin. Okay. Or you can plot in this manner also. This is also a best examples for odd signals. Here the condition is x of t is x of minus t, but here the extra minus will be added. Okay, x of t which is equals to minus of x of minus t. Okay. Example, x of t is t cube, then x of minus t which is like minus t cube which is equals to the minus t cube. So which is like x of t, you can state that x of minus t. So this is a this is about the odd signal. Now in this classification we are seeing deterministic and random signal. Random signal is also known as the non-deterministic. Okay. Deterministic means no uncertainty with respect to the value at any instant of time. So we can say that suppose if this is a graph, then we can easily say that at any instant of time there is a no uncertainty, right? So we can easily define our required value with respect to the time. So this is known as the deterministic. When it comes to the random signal or non-deterministic, then we cannot predict the exactly or uncertainty at any particular instant of time. So we cannot predict the value with respect to the time. So like this, if this is a graph means how we can say what is the exact value of the signal. So the best example for the random signal is noise signal. Okay. Now let us go for the causal signal and non-causal signal. What is meant by causal signal means if the signal exists only for present and future time, then it is known as a causal signal. So means it will present for present and future time only. The signal exists for present and future time. So if you plot the graph, the plotted graph shows like if t greater than 0, the signal will exist. If t less than 0 means x of t will be the 0. Okay. What is meant by non-causal signal means exists before t equals to 0 means it is a past signal. Only past signal. The present and future will equals to the 0. Okay. Condition x of t equals to 0 for t greater than 0. Okay. It will exist for only the past. Now what is meant by the finite duration signal and infinite duration signal means by the name only we can say that finite duration means it exists for only limited interval. So if this is the if a plot means it will exist for only limited interval like this. Infinite duration means sinusoidal you can take. Okay, exists for all time sine wave. Now energy signal. General examples are energy signal is like camera flash. I hope you all know when you take a picture by the camera, there will be a sudden flash, right? So camera flash, like sudden appearance signals or clap sound. So which means it exists for only short term or short time, dies after some time, has limited total energy. Now here it is exists for a short time, dies after some time, has only limited total energy. Now it has total energy is finite, and average power is 0. You need to remember these things, okay? You can note the energy and average power formulas, okay? Now example for energy signal is pulse signal. In technical terms, it is a pulse signal. Pulse signals or camera flash or a clapson all lies under these things only. Okay, when you plot the pulse signal, suppose if you take the example as f x of t equals to 1 for 1 less than or equals to t or less than equals to 2, means in between the 1 and 2 the signal will be the high, otherwise it will be the 0. So it exists for only between 1 and 2, means only a sudden spike, so only short duration. This is known as the energy signal. Now let us go for the power signal. In the power signal, first let us go for the general example. General examples are like electrical AC supply. When you observe the home electric current, it will comes continuously. So continuously a rotating fan. So continuously rotating fan. So they are like they continue forever. So power signals are continuing forever, means it have finite average power and infinite energy. Now it have average power is finite and total energy is infinite. So example is sine wave. Okay, AC supply, sine wave, both are same. Continuous rotating also falls under this power signals only. I hope you got the idea on energy signal and what is meant by power signal, and regarding the all classifications of the signals. Okay, if you learned anything in this video, please do a like and support by subscribing. Thank you for watching this.